Matthias, welcome. Harand, Connor. Hello. What's this doing? Slingerook. Right. Quacko. Hello. We shall continue to physics today. But first, a small side quest. Juden, hello. It's super quick, in and out. 10 minutes at best. Mystic, hello. Software should be fun, right? And side quests are fun. I try to not let myself get too carried away, but I've got to indulge myself every now and then. It's a fun new C++26 feature. Killer, hello. Causeless, hello. I've also been busy off stream. I've been a busy boy. We'll go through that in a minute. Nothing really too material, like within the code base, but I guess more infra side. Betty, hello. Apparently I'm live. Got the notification 2 minutes later. Absolutely brilliant. Okay. Right. Where are we at? If I begin this. First off, what have I been doing off stream? I've been working on the build system. Okay, I wanted to make some improvements, so I've got look at all these commits. So many commits. I feel like I'm missing a stream tag here. I'm pretty sure. Create rigid body, integrate changes, add service located. I'm pretty sure that was. I'm gonna tentatively tag that as stream 40. Stream 40 already exists. Oh, I bet I rebased. Yeah, put that back. Right. Okay. So I've changed the linker. So I now use LDD, which is multi-threaded. I now use Ccache, which is a way of caching build artifacts. So when you get your translation unit and you hand it off to the compiler, what I now do is I first check. I hash that translation unit and check to see if I built it before, and if I do, I just bring the object file back. So this massively reduces the compile times for like the third-party dependencies, because Jolt and Async like never change. What LDD specifically, because it will link a Windows executable, like a PD file, and it's multi-threaded. So it's better than GCC's LD, and I couldn't use mold because that doesn't support Windows binaries. LDD is the util. You're right. It should be LD. Yes, you're right. It should. That's a typo. Never mind. Sorry. I just put the same typo back. No, not right. Yes, mold is the other one. You've got gold, mold, LLD, and LD. And this is the only one that I could find that has multi-threading and produces Windows binaries. Maybe there's others. Maybe I'm wrong. Maybe I'm making an absolute hash list. Maybe I don't know what I'm doing, but that's where I'm at. So Ccache is cool because this will massively reduce like compilation time, especially if you have to rebuild something. Minor build improvements, sure. And then what I basically did was I spent some time vendoring the third-party dependencies. So now, if we go to our root CMake file, there's now no fetch content anymore. But what we do have is all of them checked out at the exact commit I want in third-party, and these are now checked in as source code into the repo. So this basically means that configuring is now almost instant, because we don't have to. But I don't even remember before what the issue was when we did a clean build. We had to configure, we had to check out everything, which was also an absolute massive ball ache on the CI system. So I took the view to check them in a source. I'm not a big fan of submodules. I really like the idea that the repo is the golden, the ground truth, the gold standard, whatever you want to call it. Like, you check out the repo and it has everything in it to build. The only submodule I use is one for a private repo for the assets that I do not have the license to redistribute. So that is, I guess, that is like a legitimate use of submodules. Other than that, I'm not a massive fan. I would rather have a clean checkout and everything build. So mold definitely doesn't support PE because I looked at using that first. I don't know about gold. So I did some vendoring, which was fun. I toyed with pre-compiled headers. I then removed pre-compiled headers because I found Ccache gave me basically everything, the speed up I wanted without having to change too much stuff. Yeah, so storage is so annoying because I used to be able to say storage is cheap and you can just buy a bigger hard drive. In 2026, that is not necessarily as true anymore. But like, just get a bigger hard drive. I got loads of, I got gigabytes of free space. Gold. I'm not big on the linker scene. I don't really know what is the latest and greatest is. All I know is that the LLVM one is multi-threaded, is probably better than the GCC standard LD, and produces PE files. And then I added, if you remember, we did the service locator. I've like committed to that now, and I've moved texture manager, mesh manager, thread pool, and awaitable all over to that. So let me try and demonstrate this. So we do make clean, right? So make config is now pretty much instant like that. That's it now. Like it's configured. And then if we do make build, so we're already at like the translation unit 335, right? 334. So the first 300 odd translation units were it just pulled out the cache and just built instantly. So look, it already pulled Jolt out of the cache. It already pulled Async out of the cache. All that stuff that takes ages to build is no longer there. And most of the time now it's actually linking. And I've got some thoughts on how to reduce the linking time, but not enough to care about it. I gave up with precompiled headers because I found Ccache gave me a big enough build improvement without then having to worry about the potential limitations of precompiled headers. I know CMake has kind of first class support for it and will automatically insert the header file, and I know GCC has a warning you can set because GCC is really strict on it, but like, do you know what I mean? It already feels like lots of plates spinning, whereas like Ccache gave me like a pretty big win. The only annoying thing now is that I still have to build the resources, and this does take time. And this is because of the high I/O limit between WSL and Win32. I could probably shift this off and run this natively on Windows, and then maybe copy the files back. I don't know. I'm not sure. I have some thoughts on how to speed this up, but for the amount of times we run it, which is almost never, I'm happy for this to be slow. But iterative building should now be much quicker. So questions. So that's why I abandoned fetch content, because I want everything all in the repo, all in one, and it works. Did I find fetch content a bit weird with Ccache? I couldn't remember if Ccache worked well with fetch content, but I wanted to... Oh, no, sorry, it wasn't that. It was the make config time. Every time I did a clean build, I'd have to recheck out all the repos, which is a non-trivial amount of time. So this is like pucker now. This is fast. Have I tried Zig? Nope. How do people choose a project language? There's loads of choices, and you have basically, it comes down to kind of 3 points, right? Right tool for the right job. So does the language you want give you the requirements that you need to meet your end goal, right? 2, do you have existing knowledge in that language to hit your goal quicker? Or 3, is it a language you want to learn? Like, if you ask yourself those 3 questions, you'll probably find that there's an answer in there for you. But at some point, you just need to pick one and get going. Like, you just got to start writing code. You just got to start typing on the keyboard. It's IO limited because I run the issue is, and this is probably the biggest change I could make, is that resource packer, the executable, is a PE file, right? Because it goes through the same cross compilation as the main game. So I have to, when I launch the resource packer in WSL, that gets launched as a native Windows process, which then has to write that back to the WSL file store, which basically goes through a network drive. So that's why. So memory mapping doesn't really kind of work in that case. What I really need to do is change my compilation process to build that as a native Linux executable and run that locally. And then I can use mapped files. And it'll be much faster, but like, effort. Doesn't Zig use Clang, right? Or LLVM, right? How to start? There is no other advice than like just start, like write hello world, build it, run it. Like generally, like congratulate yourself because you've taken the first step, and then just like start writing more code. There's theory will only take you so far. You just gotta pull the plaster off and start typing code. I don't want it to be challenging. Like I want to produce something, right? I want the right amount of challenge that there is interesting technical things to talk about, and a narrative that I can kind of weave through the live stream series. But I also want to produce something at the end, and like an engine I will just not produce anything at the end because I'll be forever writing an engine. So there's always a trade-off, right? Also, like I'm kind of stuck with GCC because it has the best C++26 support. Speaking of, what a great segue. Glad you brought it up. I'm going to, I don't think GCC has SIMD yet, but when it does, I will be using it because if you look at my pt3 class, it is all, this needs tidying up a little bit. It's all const expr, and the C++26 SIMD is also const expr, which means I can then have a const expr SIMD vector class, which I don't know how unique that is, but I think would be pretty cool. So yes, I am planning on using it when it hits GCC. I don't actually know if it supports it yet. I've not looked at it. I've got 1,000,001 other things to do first. So yeah, I mean, like I'm already using trunk, but like using experimental headers within that, I feel like maybe a step too far for my own sanity and stability. But we'll see. Okay, right. Anyway, service locator. Right. I basically want to remove expect, right, from my code. Expect it's old news. Expect is basically assert, right, as a function, which takes some other nice bits around formatting and stuff. But effectively, it checks the predicate, it prints out the stack trace if it fails, and then it like kills itself. Okay. Yeah, mate. It's in 26. It's been standardized. That's in D. This is basically an assert, and an assert is effectively for testing preconditions or potentially post conditions, right? And I've talked about this at length before, but I'll quickly summarize my points in that. If you have a narrow contract, as in like your function is not well defined for all inputs, you should assert on those preconditions where you can, as a courtesy to the caller, right? Because if your function says like, I cannot be called, do not set the services, so you shouldn't set services if the services is already set, right? That is a precondition of this function, right? Technically, that should be in a comment, sure, blah, blah, blah. But like for you to call that is your bug, right? I've told you, don't call this more than once. But so if you call it more than once, that is 100% like your fault. But as a courtesy, I will check that in a debug build, right? Because that will help you. And by you, I also mean kind of like me on the other side of this. But so that's effectively a precondition, right? This is a thing that must hold true for this function to be well defined, okay? Now you could make the contract wide, in which case I could throw if that's not set, right? But then like this is the whole trade-off between like narrow contracts and wide contracts. Not everything can be a wide contract, not everything can be well defined. It's very hard to test, blah, blah, blah. I often prefer narrow contracts, especially for internal stuff, because the code is simpler. Also, like not all not all it's not possible to make everything like well defined for every single input. Anyway, I'm kind of getting a bit more into the theory of it. I want this to be a narrow contract. I want you to not only call this once, plus only call once, right? And we could, there's loads of ways of doing this, but this is the way I've chosen to do it. It's basically say like assert that this has not been called once, right? And which means in a release builder gets stripped out, blah, blah, blah. The point I am laboriously trying to get to is that for this to be effectively good, like software engineering, somewhere I should be here with like, you know, only call once, right? But like that's a comment, and I love comments. I've not commented this code base very well, which is very against my normal style, but encodifying preconditions in comments is a little bit tricky because sometimes they don't get updated, sometimes they get removed, blah, 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 blah. C++26 has, I would say, solved this, right, with contracts. I can now, as part of the function signature, okay, I can codify the preconditions and the postconditions. So I can say pre impl g services doesn't equal null pointer, right? I don't think Clang format's going to like that. Give me a second, Wise. Okay. And this now, not only is this codified as part of the signature, like it's very hard to ignore this if I'm looking at this, okay? Is this constant evaluated? There was a whole, I was there for part of the discussion this with WG21, and this is what they call the constification, and it doesn't have to be const explorer. It can have side effects, but you shouldn't rely on it. So no, so you can do stuff like this, because it can't be const explorer evaluated because you might rely on checking mutable state, right? It's not just necessarily on the input arguments, or it could be on the input arguments, but the input argument isn't. A variable can't be const explorer, so like no, but there's a little bit of nuance there. You can also do post. Sorry, that's wrong, isn't it? That should be equals null pointer, and that should be doesn't equal null pointer. Ah, what a great question. What happens if this is violated? Well, you choose, right? Let me get at the code. C++26 contracts. You, as a programmer, decide the evaluating contract assertion mode. Okay. So you can have one of four modes. You can have ignore, observe, enforce, and quick enforce. Ignore means it does absolutely nothing. And I believe it's not even guaranteed to evaluate it. No, so I believe it doesn't even evaluate it, which is why you shouldn't rely on it having a side effect. So this is your release build, right? Just basically strip them out. It's like as if they were not there. Like they're codified in source code, but they don't get compiled in. Observe means it checks it, and if it fails, we'll call a handler. We'll get onto that in a second. Enforce means it checks it, calls your handler, and then terminates. And quick enforce means it checks it, doesn't call your handler, and then terminates, right? Which sounds a little bit strange, but this is basically the four possible combinations of things you would probably want, right? So I would argue, so for us in a debug mode, I would say enforce, right? I want you to call my handler, TBC, but then I want you to die. Like if there's a contract violation, bad things have happened and we should stop, okay? You could in a release build put observe on, so you log the bad things but don't die. That's a potential option, but I think enforce is what you want, right? So then basically you have to just expose this function. You have to, somewhere in your code, define this. It just has to be compiled in, and the linker will find it. The linker will look for this function, and that is what gets called on a contract violation. So let's do e source. I'm going to try and show this now because I've not tested this yet, so because this could all be a total disaster. Let's just do core. Is it core or is it a util? I say it's probably core because you're going to want it there, right? So let's do handle contract. Don't like that. Contract violation handler.cp. Okay, right. So hash include contracts. Don't want it in a namespace. You doesn't have to be external C, but you don't want it in a namespace. That should be the plain function. So I'm just gonna copy this. So then hash include utils log. So what I'm going to do is I'm going to say when this happens, right, I will log it, and then obviously we could convert this to an exception, but I think we'll use the mechanisms that are already provided to us and die. So I'm going to do log. Sorry, FPS. Log error, and then we get, if I can find this class because it's not always obvious. There's the contract, right? So this contract violation type gives us it tells you the kind, whether it was like a pre or post. It gives you the semantic, so like I guess in this case it'd only be probably observe or enforce, whether it's terminating, the detection, but basically the main thing you get is the comment, which is what I want. So that would be the text that you put in the pre or post. Okay, so that's so we can print that out, and then you get the location. I'm not going to use this. I'm going to print a full stack trace, but you can get stood source location from this as well if you want. I believe it is thread safe. There is no mention of thread safety with. Is it thread safe? What a great question. I believe so, but I'd have to check. I'd have to find the paper. P2900, I think. Very controversial paper. Not everyone's a fan of this. So contract. So contract violation. I'm going to do cv dot comment, and then I'm going to do. What am I going to do? I'm going to hash include stack trace. I'm going to do stood stack trace current. I might need to put some numbers in there to make this a bit cleaner, but basically that's how it's going to work, right? So this will just call that. Yeah, I don't. It's a great question. That I don't actually know. What does it say about threads? It doesn't say anything about threads on CPUref. I'd have to go back and read the paper. But also, like, I guess your point is it needs to be fast. But if you're going to die anyway, then it doesn't need to be fast. But I guess that then depends on what mode you do. So the implementation defined part of this is how you tell the compiler which mode to do, and that is via compiler flags. So there's no way in source code to say what mode you're going to be in because it needs to know kind of a priori to it running what it's going to do. So the implementation defined way is your compiler has to expose some flag to do this. So let's just core CMake lists. Do I not have a core? Must have a core. Source core. Everything in core so far must be header only. That's really fascinating. That fine. And let's do copy source graphics to source core. G source core, and then what did I call it? I call it like contract violation handler. Contract violation handler. Okay. Let's just check this builds with this in it. So I think this is one of the big sticking points is what do you do if your library exposes this already? I suspect it is a linker error, but I'm not entirely sure on that. That's a really good question. Is that a linker error? Oh, it's because I've not included this, have I? Sorry. CMake source. So I will be, now that we've got this wired in, I will be using this a lot more because I think it's really good, and I want to get I want to put some hours in with it to kind of get the feel for it. No previous. Oh, I need to change this. Not this bit. For some reason, it wants previous declarations, and it's really, really annoying. Ooh. Have I got to change the flags first? Now you're going to see where I thought this was going to be a great idea to do, and then didn't really test any of it before. The only note I made off stream was what GCC flag I need to pass into it. So target. And I want -f contract evaluation semantics equals enforce. That's what GCC decided to do. Oh, semantic. There's only one of them. I might need to include the experimental C++ lib as well. I'll have to check. Yeah, this is missing something. I think I might also need... oh, no, I've got... Ooh. This is saying it's expecting it to be a const ref, which I wonder if they've changed that. Anyway, this doesn't really get us any closer to graphics, but I thought it would be fun. That's better. Ooh, interesting. CPU ref must be out of date. Peru, 6 months. Crazy. Thanks very much. Yeah, great. Glad you're here. Glad you're having fun. Okay, so let's now... I mean, let's just check this runs, right? Okay, so that's fine. So what we can do now is let's do main, let's do set services. So if we call this twice now, which is obviously... Oh, I see. Clangd's going to really not like calling functions with the post conditions on, but oh well, he can suck it. You cannot let Clangd get in your way. So hopefully this will go bang. Boom. There you go. Contract violation handler hit. And then you even get the text, right? And then I don't want this. And I don't want this. And I don't want this. What I want is this. So I think I need to skip, because this is just machinery, right? 1, 2, 3. because I want the stack trace to point. The first line should be where the contract violation occurred. There's also a new assert function called contract_assert, which we can use instead of assert, which will trigger the same mechanism and automatically means we can automatically toggle what we want. There you go, 384. That's what we want. So we know what failed, and then we can get the line on it. So if we go back to main, 384, bish bash bosh, remove that. I think I want it from the calls. Oh, actually, a good point. Should it be from the... Yeah, I might want two, actually. Because that will give it from the actual handler itself. Yeah, okay, I think that's right. But anyway, that's contract. That's C++26 contracts in a nutshell. Pre and post, we're going to be using those a lot more. Oh god, hay fever at the moment. My face is going to explode. I do apologise. Right, let me just add contract. This physics branch is an awful lot of like drive-by refactoring. Okay. There's a question. I'll get to your question in a second. I'm just trying to think what we're going to do. Right, so let me just run a quick reminder of where we're at. So we've got our little level. We've got some coroutines that handle like repeating events. So that's like the flickering light and the pulsing red light up here. We've also got in the logs, we should see that there is a invisible physics object falling due to gravity. That's all wired in. We just can't see it. So our next job is to write a debug renderer for the physics engine so we can see those, and then we can start extending this UI to be able to build effectively static colliders for the geometry. Then we can add a character controller, and then we're done and we can ship it. Right, sorry, there's I'm going to go through the backlog of points in 1 second. Ignore the big open gap here. I'll fill that with something. Okay, right, so I've done the I did a bit of a refactor as a debug render already off stream. We talked about that a stream or two ago. Anyway, I'm pretty much a perfectionist, and I found myself restarting projects time and time again with no real progression. For instance, I've been restarting a project I've been working on since December 25 because I find different ways of doing something, or I feel like I'm getting too lost in my code. How do you find the perseverance to continue through? I find it a massive mind block, and I struggle with. It's definitely like a it's a mental kind of, it's a change in mentality is what I'm trying to say. You have to accept that code is not perfect and never will be perfect, and I'm a big fan of like just doing the next thing that makes progress, even if it's not great, even if it's a bit hacky, even if it feels gross. You have to make that relentless march towards the end. There's loads of examples we've done this on stream where I'm like, there's so much better ways we could do this, but like it could take 5 streams, so let's just do this now and we'll come back to it later. I think someone suggested streaming. Like that's quite a big jump to to do, but I find streaming has helped me keep on that relentless march of progress, because I have to show up, like it's twice a week. I have to show up. I have to make progress. I have to kind of explain and justify what I'm doing and try and be entertaining and engaging and all that gubbins. But like twice a week, 2 to 3 hours a week, 2 to 3 hours each time, like I have to make some progress. And I allow myself a few side quests, but I find that really does help me kind of keep the bigger picture in mind. But here we are. I told you 10 minutes. 10 minutes. Do I prefer templating or inheritance to change the behavior based on different things? I'm open to any and all paradigms. We use both in this. I've got some small inheritance change for some things. I've got templated code for the other. It's kind of, I'll take a view. Again, it kind of relates back to the previous point in a certain sense. Like given that fork in the road where I need to make that choice, I will look at all the information I have in front of me, what gets me to the next step quickest, and also what is fun. So normally templates, and then pick one and go with it. And if it's wrong, fuck it, it's wrong. We go back and we fix it later. It's just every decision has to be in pursuit of the relentless march of progress, right? And you just have to accept that sometimes it's not going to be great. Anyway, right, let's do physics rendering, because I have somewhere. So from the previous project, we wrote a debug renderer, which is actually now a terrible class name because we have a debug renderer, which means something else. So this will be the debug physics renderer. But basically, you expose a bunch of methods, and then we hoover up. Jolt will feed us lines, like individual lines that we need to render, and we will hoover them all up, and then we will yield them up into the machinery that already renders debug lines, because not that. We already you can't see it there. Where's another light? This one in here. We already have a line renderer, right? Oh, in fact, actually, if we click any of these, we get lines for the AABBs of all the submeshes. So we already have machinery for rendering lines. It's just a case of just like feeding those lines into it. Enough gas in, more CPPing. All right, so let's do e source physics. I'm tempted to just call it like Jolt. Do I want to call it Jolt debug? No, let's call it physics debug renderer.h. Okay. Hash pragma once namespace oops. And now we're off to the races. So let's hash include our physics jolt, right? Which unfortunately is just, I'm not a big, Jesus Christ. I'm not a big fan of like coalescing all of your headers in one file and then just including that. I'm a big fan of only include what you use, but something jolt doesn't play very well with the latest GCC, so we have to massage the headers a little bit to do what we want to do. There's some drama going on. I'm out of this for a minute. Yeah, mate. Oh, we're reflecting up the wazoo. All of our YAML serializing all uses reflection. So we can just hand it any class and it will automatically serialize it to YAML, which is really nice. So hash include jolt renderer debug render. I don't know what a debug renderer playback and recorder are, but sure. So I have one of those, and then okay, fine. So let's do class physics debug renderer public JPH debug renderer simple. So this is Jolt. Basically, Jolt is quite hierarchical, which is fine. I've not opposed that as a design choice or paradigm. And it has an interface for debug renderer simple. You create one of those, you then shove it into a debug renderer, and it will effectively call back to you. I don't know why Nightbot keeps falling over. Like, I literally have nothing to do with it. Oh, it's back. So we're going to want a auto draw line. I'm going to copy these because it's just a lot of typing. All right. Sorry. Okay, right. So this is one of them, and then we have auto draw triangle override. Sorry, this is I'm just going to declare these, not define them. So these in a good old-fashioned CPP file, and then auto void override. Okay. So this is the interface. So whenever Jolt thinks it should draw a line, a triangle, or some sort of 3D text, which we don't really use, it will call these functions. And then I'm going to want to have a hash include. I think I've got a graphics line data. Hash include vector. Okay. And then I'm going to want some sort of auto yield lines, which will give you a stood vector of line data. So yield, what I mean by yield is that, so we'll have a stood vector of line data lines. So this will continuously get called during the physics simulation, right, and fill this up. Then once the physics simulation step is done, we will render the scene, and then our debug renderer will get called, and then that will be like pull all these lines out. So yield here will basically say return me all the line data and reset internally back to like no lines. So on the next frame we start filling it again. That's what I mean by kind of yield, as in like rather than just return a copy, like literally give me all the data. I think that would be fine, and then I think that's basically it. Because of our kind of macro architecture, whilst the physics system is multi-threaded, it does like scatter gather. So we'll do physics simulation, use a load of threads, come back together, and then like renderer, maybe use some threads, come back together, update the events, use some threads, come back together. So by the time we hit the debug renderer, all the physics threads should have like calmed the fuck down, right? They shouldn't be firing. So I'm pretty sure I'm willing to take a gamble on the fact that this does not need to be thread safe because of the way we're going to call it. But we will see. Okay, I need some implementation for this. So source physics that. KV. Why am I in physics layer? What's going on here? It has gotten confused. Okay. Physics. BS. Source physics. Debug renderer. What is source physics? Physics debug renderer CP. Right. Okay. Sorry. My bad. Right. Include. Again, don't really know what I'm doing. Making up as I go along. what we call this class? The physics debugger renderer. Right, that was a load of, apologies for that, a load of rando typing. Okay. Hey. Okay, right, calm down, no one panic, we're there. Not that I would suggest you were panicking at all. Maybe I was the one who's panicking. Okay, so then we need to start. What did I do last time when I did this? What does my line data look like when it's at home? So it's a position and a color. So I want to do lines dot pushback to native from to native color, because I think you basically push points like that. So then we go to Jolt. We realize we've not done all of this. And then we do to native color. And this becomes our own color. And then we do oh, I like how there's getters for the vector, but for the color, you can just raw public values. Sure. At least we're consistent. Oh, they're UNATs. Oh, of course they are. But I'll spell color correctly every single time. Apart from there, I spelled it wrong there. I will give you there. That is incorrectly spelled there. Okay, so that's going to be 0 to 255. So let's do const expra auto convert equals third. So it was UNAT v return. It's gonna be stat. Actually, no. What am I doing? Can I not just do over 255.0f? When will that give me the integer promotion? Sorry, the float promotion. I think it will. That will implicitly convert the whole thing to a float and then divide it. Yeah, thanks. Good. I'm trying to do as much from scratch as possible, so I'm trying to not. I mean, clearly I'm using Jolt here, but like, it's good to know, and I'll look it up. Thank you very much. Okay, right. So now, if we return from whence we came, not there, absolutely not there. Hate everything. Right. So that, why is it not pushing? Oh, hang on. Because that'd have to be in place, or we construct it. Makes no difference in this case. Whether you perfectly forward the individual components or just push back with a PR value makes no difference. So this is then going to be, I think I then basically say draw line between v1, v2 with color, v1, v3, and v2, v3, right? That should give me a triangle. And then this is going to basically, I'm going to leave this unimplemented because I do not care. Oh, I see what you mean. Okay, cool. Thank you. Okay, and then what I'm going to do is I'm going to do auto copy equals lines equals, sorry, stood move lines, return copy. So that will actually, let me think about that. Do I want that? I think actually what I technically want, because moving leaves it in a valid but unknown state, I should probably be explicit and do auto copy equals stood vector line data. All right, and then I should do stood ranges swap copy lines. That's better. And then return the copy. This should work, right? So we construct an empty vector and then we swap it, which is super fast, by the way, because it's only going to change implementation defined, obviously, but effectively it's only going to swap 3 pointers. And then we'll get the old one back. We might even get an RVO as well, potentially. So this could be like super quick. I think that's about what I want. Right, okay, right. So how do I wire this in? How does this work? How did I do this before? Help. Physics system. Right, this is my miserable physics system from last time. The new one is obviously so much better because we're rewriting it. Debug. So I had a debug renderer object. Okay. What did I do with that? I called clear. I'm getting rid of the idea of manually clearing it because it should be cleared from the point that we yield it. So you have to. That's it. You basically say to Jolt, draw this thing using this renderer. So please draw all the bodies, so rigid bodies, presumably maybe soft bodies, I don't know. And then like we have to do something special for the character controller, which we've not done yet. So we can draw the bodies, and then we just have to expose some way of this. So what I think this needs to be optional. Right, so if we go physics system.h, let's do hash include physics debug renderer, and let's do hash include optional. And what we're going to do is physics system is going to take a stood optional physics physics debug renderer. The physics can have variable FPS. At the moment, I've just locked it because I'm using vsync anyway, just to make it easier, but that's a future expansion to have, to decouple the time steps, right? So we want the physics to run at a lockstep, but the graphics to run, I don't know, at least as fast as your frame rate, right? So potentially faster. And then we're going to have a stood optional physics debugger renderer. Okay, and then this is also going to have then a auto renderer stood optional physics debug renderer ref. Okay, because I don't want to return the whole debug render. I want a reference to it, whether it's there or not, right? I should be able to query whether it's there or not. So this should equal stirred null opt t. Opt. Okay. So you can give it a debug render if you want. It's entirely up to you. We could even technically actually have this as just a boolean of whether you have one or not, and then make it entirely internal. But there's no reason to construct this externally. Actually, I think I prefer that. Take it back. Full debug render equals, I know, true. Probably false. Could be true. Should be an enum, really. Should be an enum, really, because passing rando true. Fine, fine, fine. I went on quite a personal journey then. The reason you should avoid passing arguments to functions, like if you're just looking at the call site, you want some semantic. You want to be able to glean some semantics from that, right? So if I just pass in like true or false, that could literally mean anything. Whereas if I pass in this, at least it's explicit what's going on. Could template no. Could I template it? No. I could template it. I won't template it, but I could template it. Okay, and then this. Physics system. Okay, so at the bottom here, we're then going to have the debug renderer is going to be. Is there a way I can do this? I basically want debug render mode equals debug render mode on debug. Sorry. Can I just do physics debug renderer renderer third no opt. Is it gonna let me do that? I've got a feeling I'm gonna have to do something like third make optional. There you go. Oh, is it just because I spelled that wrong? Oh, it's staying there now. Why is it not like that? Okay, fine. Is that why it's not? I reckon that's why Clang these haven't a fit. To be fair, I did have this before. I do so hate macros. Well, no, I don't know if I want it in the jolt header, right? I probably want it localized here. So it should be included. Oh, no, it's going to have to be in the jolt header, isn't it? Yeah, you're right. Because I don't know the order these are all included in. Oh, I hate everything. This should be controlled. This should be controlled via a command line argument, but for now, I'll just slap that in. I don't know why it doesn't like my make optional. What have I done? No, it's called for make optional physics render. Is it? Does it not have C? It probably doesn't have CTAD, does it? Because it's not constructor. Okay, fine. So that's going to be. Is it just because I had a typo? Can I just go back to doing? Can I just get the type inference? God damn it. God, I hate everything. Come on, Steve, let's get your act together. Yeah, it's fine. Oh no. Ooh, it's because I'm not building it. It's fine. Link error. Solve that later. That's the linker's problem. So somewhere in update, I want basically if no, I don't even need that. If debug renderer. Lost my code now. I lost where I was. God, I hate everything. System. I want static const auto settings equals jph body manager. I don't actually know what's in here. I assume this allows me to control like what gets rendered and stuff. Draw support functions, draw support directions, support. Yeah, okay, fine. So if I want to control what gets rendered, I can use this. So when something doesn't get rendered, and I'm convinced it should be, it's going to be this. Physics system dot draw bodies settings is the stood. Hang on a minute. I want to get the I'm not sure if the precedents will support me with this. Nice. The old ampersand star. Yeah, I've done a bit of refactoring of MGUI, but not loads. And I did it off stream anyway, so you didn't actually miss anything. It was just me over a few evenings with a few beers. Okay, right. So now, let me just wire in this before I forget. Physics. So we've now got physics debug renderer. So that blends. No, I didn't refactor that with the Oracle, actually. I tried to use the Oracle to refactor all of the managers into the locator, and it made such a pig's ear of it. I threw it all away and just did it manually. Undefined symbol. I feel like I can't find my debug renderer. You know? Which must be to do with that include. Can't find debug. Yeah, it's probably a virtual destructor though, right? But then it also can't find the the vtable for this. It also cannot find these functions. I don't think we do. Like this is definitely a Jolt thing though, right? It's in the GPH namespace. Something cached. This is the only issue now with like, the Ccache is great, but you're forever second guessing yourself about whether it's something's been cached. It does seem like a missing header. I got. So there's like this as well. There's something fancy in here. So so if I haven't got that, then this will fail. So it's definitely in there, right? And then it does have the virtual. So where is the debug renderer? Why is that not being built? Quick look at the CMake file. Is there some voodoo I had to do to get this to work? No. Nano, thank you for being here for so long. Yeah, just looking through the old code just to see what I did. I definitely included that. Was there something else I had to do? Because the physics system is probably what's going to get included first. Oh no, because I pushed it all off to the CPP file, didn't I? Curiouser and Curiouser. Have I... Oh, hang on. Have I got like some rando jolt include again in the place I don't expect it to? Got jolt there. Physics debug renderer. No. I'm cross-compiling with GCC and MinGW. How annoying! What am I missing? So it's definitely. You can see here, it's like it's in physics system, so in physics system CPP, and then physics debug renderer, and then main. It's like I can't find it. Why? I just check the C. I actually didn't check. I said I was going to check the CMake file, and then I absolutely did not. So there's no special in the last project. There was nothing special about Jolt in the CMake, and this seems to be. I could do a clean build, but it just is just a bit of a pain. I'm gonna have to do it just to convince myself. So. Now you'll see how long a full build takes. Yeah, Nightbot is really like he's gonna have to have a pip, I think. Do 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 do. It's quite a meaty project this now though. I think this project's going to go on for longer than a year, seeing as we are like within sight of the halfway mark. I haven't even got physics working yet, but we'll see. I haven't even got for an FPS. I still only have a gun, and this is the 41st stream. There's no pew pew yet. Pew pew. I was going to say, I really hope that wouldn't work, because then I'd be forever worrying about Ccache. I'm going to go to, I guess, the Jolt source and see if anyone else has had this issue. Yeah, it's an awful lot of dependencies, which is why Ccache has made such a big difference, because they don't really change. Issues. Show me undefined symbol. Show me undefined symbol. Nothing in open. Better just check everything in case it's been solved. Nothing. Okay, fine. Let's just search for undefined symbol. There's no way that returns nothing. Clang doesn't support contracts or reflection. It doesn't have great C++26 support yet. So where does... We're gonna have to go through a deep dive through the Jolt code, right? Because basically, as we let's piece this together, right? Let's the advantage of rendering of vendoring is that I can now super easily go through the source code, right? So this is a debug renderer. He says, fuck's sake, thought that would work. Debug renderer, and then this has a virtual debug. So I should be able to now grep for all code, right? So let's... So it's in... So it's here, right? So so why is debug renderer.cpp not being compiled, as far as I can tell? Let's do debug renderer.cpp. So that's in the debug renderer... hash including the CPP file, my favorite. Hack to still compile your own inside the test framework when Jolt is compiled without. So I did, interesting. One of the other things I did do was I did tweak the Jolt build flags to not build the tests and stuff. So this seems like there's a bug or something they had there, but this is in the test framework anyway, so this shouldn't matter. So wait a minute. This is test framework, so it shouldn't matter. So why is there nothing else including this? Why is this not in any of the CMake files? You know, right? Okay, fine. Let's just do E third part. Oh, Q E third party Jolt physics. Oh, they put it in build and then oh, fuck's sake. Themate list. So where do they add the source files here? Don't care. Actually, let's just. Is there anything in here about debug renderer? Here we go. Enable debug rendering. Debug rendering distribution will override the setting. Enabling this reduces setting to enable the debug render in all builds. I don't want it in all builds. I just want it in my build now. Maybe that's something we need to revisit. That's the only thing in there that mentions that. Yeah, we could try building the tests. Let's go to third. So now I have third-party CMake, which controls everything, right? So somewhere in here is... Oh, I don't... Oh, here you go. Ha, that is definitely what an Oracle inserted comment there. interesting, because I said to the Oracle, can you look through all the jolt flags and find any that I should disable to increase compile time? And it's like, yeah, mate, you want all these. Let's just get rid of all this shit. I might have to blap the cache again. What did I have on 77? Oh, interesting. Yeah, I bet that's it. Make config. Don't use LLMs, kids. I'll lead you up the garden path. That is outrageous, that. That's what I get. That's what I get. Trying to be clever. I can speed up the build time a little bit without having to think too hard about it. No. I feel like obviously need different error. Now cannot declare build physics system between a simple broad phase layer. Didn't we have this before? Didn't we have this before? Yeah, we had this before. It's changed. Look, cannot declare broad phase type. The following virtual functions are pure within. Oh, there's some other debug shit, isn't there? Oh, hang on. Yes. Give me a second. One of these. No, hang on. Hang on. Hang on. Here we go. If you have external profile on, then you need to do this. So I do need to disable the profiling one. Profiling debug on release. That's what I want. So the build system landscape for C++ is miserable, right? Because there's no standard, there's no there's no standardized system. The standard itself does not care how you build your code. In fact, it's very much not concerned with you building your code at all, just making sure that you follow the letter of the law. CMake is probably the most popular, but it's just because everything is confusing. It's not technically a build system, it's a meta build system. You describe in CMake's DSL how and what you want to build and how your project's laid out and what connects to what, blah, blah, blah. And then you give it an output, okay? And it will generate you a project in that output format. So to give you an example, you can describe your project. You can take my CMake project, for example, which has the libraries and the executables and the flags and all that kind of stuff. And you can say, generate me a Visual Studio project for that, and it will do it. Or generate me an Xcode project, and it will do that. I'm using it to generate a Ninja project, and Ninja, I guess, is technically the build system. You could also get it to generate you a Makefile project. So yeah, it's, I mean, I don't know what scaffolder is, but sure, sure. The thing is now, the way it's kind of worked is because CMake is so popular, a lot of tools will directly consume CMake. So Visual Studio, and VS Code as well, you can point both those at CMake file, and it will consume that internally and use that internally to generate its own files. But it looks like it's just reading the CMake file. So CMake has, in a way, with certain tools, it looks like the build system because they take the burden of you having to do all the generation off your hands. Right, we've linked. We must be working now. Let's just check this still runs. What a fucking nightmare that was. Oh, Jesus Christ. Oh, because I've got the resources. Let's just chat while this builds. Yes, CMake is the best of a worst bunch. There are other build systems. You could write raw make files. You could use scones. I would not recommend it, but you could. I'm sure there's others as well. There's obviously all the platform-specific ones. Like Visual Studio, that big Visual Studio has its own format for project files. The VS Proj file. It's all XML under the hood and grim. It also likes to assign random UIDs to everything, and it gets really weird when they change. The three big ones are GCC, Clang, and MSVC. Correct, yes, because you have to remember C++ is not... Most languages will give you a reference implementation, right? It's like the creators of the language will be like, you're probably going to want to use this, so we'll give you a reference implementation. You've got C Python, you've got Java C, you've got Roslyn or whatever it is for C Sharp. Like when Microsoft writes C Sharp, like they give you a compiler for it. C++, like I guess like C, COBOL, Fortran, whatever, international standards, right? You just get... For C++, you just get a 2,800 page PDF, which explains in miserable detail how the language works. It's kind of up to you to interpret that. So because of that, there are now kind of three competing compilers, right? So you've got Microsoft's one, which is MSVC, and then you've got the two open source ones, GCC and Clang. They are all uniquely different in their own weird and wonderful ways. They all implement different subsets of the standard because the standard is so huge they're not yet implementing all of it. They have different warnings, different errors. There's just such a thing as implementation defined behavior. So they are, in certain circumstances, they are allowed to differ in what they do. So yeah, it's a little bit complex. I try not to get bogged down too much in it. Like I would probably say, personally, if you're on Windows, pick MSVC. Like go get the Microsoft build tools, go get VS Code or Visual Studio and just get something going. Because if you're learning, you just want to write code. If you're on Linux, I would just apt-get install or whatever the latest available version of GCC or LLVM or Clang. Clang is better in a lot of ways. It has better error messages. The design is a lot more modular, although actually saying that GCC's internal architecture has improved a lot. But if you care about the kind of bleeding edge, at the moment, GCC has the best C++26 support, which is why I'm using it. So yeah, that's kind of like a whistle-stop tour of the misery that we have to deal with. Yeah, I don't really follow Zig, so I don't really know what they're doing, but writing a compiler is incredibly complex work. The thing with like Clang, right, or LLVM, because Clang is just the front end, is that it's very modular, so you have the front end and then you kind of have the middle end and then the back end, right? This is why a lot of languages start off using LLVM, because they only have to write the front end. You just have to write something that turns your language into a Clang AST, and then from that you get, not only do you get all the backends, so not only do you get like the ability to create x86 executables and ARM executables and MIPS and whatever, Super H, and then for all the different platforms as well, you also get all the optimizations. Like Clang's been going a long time. There's an awful lot of clever optimizations it does, and you kind of get those for free. So this is why Zig, Rust, maybe Odin, I don't know, all use that. It's a really good question. Like, which version should you start with? I would say the fundamentals probably have not changed. Like, I think C++ 20 is probably a good default now. Like, it's 6 years old, right? It introduces some big changes like modules, concepts, coroutines, like, you know, stuff that you would probably aspire to using. I think anything, I'd say 17 at an absolute minimum, because 17 includes some really important vocabulary types like optional and variant. It includes the file system. So I'd say 17 is an absolute baseline now. But but I would. There's no problem with just getting 26 in, right? Because it has some interesting bits and pieces. But if you're learning the language, I wouldn't get too bogged down with it. Like what you want to hope to get to is that you can be writing code, realizing some of the idioms and paradigms that get used, and then look at the newer stuff and like, oh, that makes my life easier, and then you can kind of learn it from there. That is an excellent point. 23 does give you println, which is a massive game changer. So actually, maybe if you can get 23 and use to println, then you can remove all the IO stream misery from your life. That's a really good point. Yes, sorry. It's a problem with sort of trying to come up with all this stuff off the top of my head. Is I do miss some key parts. 23 does give you println, which is an absolute game changer. So if you can, then that, which is supported across all the major compilers, by the way. So there's no reason you probably couldn't start using 23. You are welcome. Right, this is not getting us anywhere. Did this run? I mean, you can use std puts and std format if you want. It's just extra typing. Right, okay. This box still boxing. So now I need to go to this is where we see if it all works. Debug renderer, the actual debug renderer, the graphics debug renderer. It's easier to add stuff to as a general rule of thumb, it is easier to make a library change than a language change, because a library change is just more C++ code. Do you know what I mean? Like you're just adding extra header files for people to use. Obviously, it's not saying it's easy, but it is easier, right? And this is why, like, going through the standardization process, WG21 would probably prefer you propose a library change where possible, and only make a language change if it's really necessary. Because to make a language change, you have to change the compiler, right? You're modifying the compiler, which is obviously not a trivial thing to do because they are not trivial bits of code. But it is it's much easier to just write a new header file and ship that. Yeah, exactly. Yeah, and also like, if you don't like the library implementation, you can just like not use it. You know what I mean? Or we can find an alternative one. If you don't like the collision resolution method in std map, you can just go and you can use the boost one, right? Okay, I've got my debug lines. Where do I here we go. I think I want to do here, if service, I think Clang D is given, oh no, it's because I'm recording, physics system dot let's do auto. Is this going to work for me? Auto physics debug lines equals service dot debug renderer dot hang on, I'll get there in a minute. What am I doing? Physics, dude. Right, what was my... No, that's you. Oh, sorry, it's the physics system, isn't it? Sorry. Physics system... I don't think I even implemented this. That's going to be a linker error, isn't it? Did I even implement this? Or I get carried away? I don't think I did. Right. I mean, Booster's got some Booster's got some good stuff in it, right? I don't think I can just do return debug renderer. I think I need to do dot transform auto debug renderer. Sorry, auto e can I do decal type auto return e? Yeah, Boost is a popular collection of libraries. Like, there's as with everything C++, there's politics around it. Like, I don't use it in this project, but I've basically every shop I've ever been at has used Boost in some capacity. There's some good stuff in it. There's good alternatives for a lot of stuff as well. Abseil's pretty good. Folly, C++ gives you the freedom of choice, right? And the freedom for you to choose what you want. You're right. I might need to make. Yeah, okay, fine. What I was hoping is I could promote this. Hang on. With decal type auto, I was hoping I could preserve the value category and effectively yield this up as a reference and then automatically make this work, but I don't think that's going to work for me. Does transform got to return another optional, or does it automatically wrap it in the optional? I can't remember. This is value invokes f with a contain value as an argument and returns an optional that contains the result of that invocation. That's what I want. So I don't know why this isn't. Let's see there. I think their hash table is pretty good, right? I think they've done a lot of benchmarking on it. Their latest release of the hash table. I don't know if it supports heterogeneous lookup, but it's pretty good. Const. I don't want that. Where's that const coming from? Is it because this method is const? I bet that's it. I bet. Oh, if this works, that's some beautiful C++. That. I think it might work. In fact, actually, can I just do it without the decal type auto, or is it going to probably try and turn that into a value? Let's try and copy it, won't it? Yeah. Oh, nice. Not often you get to use decal type auto. That's basically saying reduce the return type using slightly different rules, and if you're returning a reference, preserve that reference. I mean, std regex is pretty much the butt of all jokes, unfortunately. Okay, so now I've got an optional that, which is fine. So now I want to do debug renderer. Let's just write this normally and I'll see if I can. So let's do auto ref physics debug renderer equals services physics system. You might need to hash include that. Hash include physics system and hash include physics. Yeah. Dot debug renderer. Oh, have I not got the service locator? I do have the service locator in here. Why is that being funny? Pretty sure that should work. Cannot bind non-const L value reference of a optional physics DRM to an R value of type. Yes, I guess you're probably right, but I should be able to do that. Nice. Okay, so I'm allowed to bind. I cannot bind an R value reference to an L value reference unless it's const, because that will then persist the lifetime of it. But I can bind it to an R value reference. That's what it's pointing, because this is a PR value, right? So now I should be able to do if physics debug renderer then debug lines dot append range physics debug render dot yield lines. If that works, that's really nice, because this basically just NRVO, well, even if it's not NRVO, right, it's going to yield it up as an R value. Sorry, the result of yield lines will be a PR value, which means it then gets perfectly forwarded into append range. So it should basically just move those line data straight into the vector. The standard approach, right, as in the only thing that is correct in the standard is the hash include header guards, right? So hash if and def whatever. Pragma wants is a compiler extension. It's not in the standard, but it's basic, and it is the only compiler extension I really use, because all compilers pretty much do what you think it's going to do. So remember yield lines. What? Oh, is that an optional? So is that got to be like that? I think we should have a poll. I think it's been a while since we polled the room. Do we think this is going to work? First time. Do we think we're going to see the outline of a box falling? Let's poll the room. Let's get a temperature feel for this. Start a poll. Is it going to work first time? Yes and no. Start poll, and then for the people on Twitch who like to gamble. Our prediction. Is it going to work first time? Yes. And no. I'm hoping we can dive through the wall and see. I want to see the outbug. So I guess to set parameters for the experiment, I need to see some debug lines. If the debug lines are massively wrong, I might consider that a yes. If the game immediately crashes at the start, I might not consider that a no. If there's some other issue, if the issue is not related to the rendering, I've just fucked up somewhere else, then I would potentially re-roll that. But what I really want to see is the box falling. Right, Twitch prediction has ended. I will end the YouTube poll. And poll. Right, so we got 74% yes on Twitch. I think it's going to work, and we've got the poll has disappeared on YouTube, so I don't know how many people voted, but I hope you remember. Right. Okay, so it's very close. People believe. I'm not gonna lie. I'm not seeing it. For a fair experiment, we will run it. We'll run it one more time. I'll immediately backpedal. But I see not a box. Oh, wait a minute. It only does it if the debug layer is on, isn't it? Hang on. That might be my fault. You have to have the debug layer on to see the debug boxes. Nah, still fucked. Am I getting any debug lines? I'm getting those debug lines. So it's definitely debug line in. I get it. This is my bug. So I think I have to say that this is no, because I fucked up. Ooh. Oh, I messed this up so badly. Pretty sure that's right. Yes, indeed. One must opt in to debug rendering. No matching rule for physics system debug render mode. Oh, I put it in the wrong place. Sorry, I've been an absolute tit. Sorry. It's here. Either way, I still forgot to put it in. The joy of default arguments, am I right? This will work. I don't know if the CPU got that arg. I think it got that arg. Come back. Why is it really like jittery? I feel it's kind of jittery, but maybe I'm just doing something wrong. Oh. We're doing it. We're doing it, guys. I guess, yeah, it is one step a frame, but still, like, everything else moves. Maybe, I'll have to think about it. Yeah, it's true. Okay, fine. We'll sort it out later. Oh, Jesus. Right, what have I done here? so I like how this wasn't saved as well, which is a little bit worrying. Just play for time now, because let's check that works. I'll start committing stuff up anyway as we rebuild the resources. All right, okay, so let's do. I just noticed that this diff was smaller. Right, okay, so fix jolt build flags, remove AI guesswork. No. Update jolt.h, add physics debug renderer class, documents integrate debug renderer into physics system, render physics lines, and this is lol, enable debug rendering for physics. Still right. What's next then? We need to. There's a load of other gubbins I need to do around Jolt. Like I need to integrate it into our thread pool system, stuff like that. I think that's necessary now. I just don't want to forget it. I should write that down somewhere. I guess the next thing is to start integrating into the editor. We need to be able to have. We can use that cube to test with, but we need to be able the ability to create static objects, but also they're static, but they need to be movable within the editor. I don't know. I've lost the to-do board. It's gone. I can't remember. It's on a side. It's on another project somewhere. Is it? Let me just. That's a good point. I think it's on the. I think it's on the secret repo. The secret repo. Hello. Thank you. FPS. Right. Give me 1 second. I just sort of flail around. Secret repo. Projects. Private. Here we go. Here we go. Let's add integrate thread pool into Jolt. Done. I put that under tech debt. I guess it is kind of tech debt, isn't it? Bloom, done, mate. Completed it. Move that over. Integrate Jolt, done it. Physics simulation, done it. Might leave that one. That's what we're currently working on, is physics simulation. After that's character controller. Right, so I think what we need to do next is I need to have a think about how I'm going to integrate this, because I think I'm going to just build out block level geometry to start with. I think that's just the easiest way to get us going. I don't want to have to build like a massive pipeline of assets and stuff like that. Bye. So what we need the ability to be able to do is probably from this view click and drag boxes and then stick one on the floor, stick one for the walls, and then do like a basic block out. So there's kind of there's kind of two options we have here, an easier one and a more complex one. I'm happy to ultimately I will make the decision, but I'm happy to discuss it. Yeah, stairs, TBC, all complex stuff like that, like ladders. I want to have multiple levels in the geometry. I want to have like vents you can go through. That's like, again, relentless march of progress. Like, I can't be worrying about those problems now. The problem I have at the moment is that in this view, I can do this. And I don't really want to be able to do this. I want to be able to kind of walk around and make it feel like I actually live within this level. So we kind of got, there's two options, right? One is we just completely separate out physics from entities. So I have like a new physics window here, and then I can click it, and then I can drag boxes around, and we can just slowly block out the level. The problem with that is if, like, I don't know, say I want to move this here, right? I will now have to move all those physics objects, and it's going to get quite difficult, I think, to see what's going on. So the other option is that we have the top level game entity also own a collection of static bodies, and then they parent it to this. So I have to sort of click this and, like, I don't know, click this to draw the boxes, and then they're anchored to that. And then when I move this, or I translate it, or whatever, or I scale doesn't really work at the moment, doesn't it? Yeah, I suppose it then does that. And obviously you're going to have multiple potentially colliders for it, because this is hollow, right? So I'm going to have a box here, and a box here, and a box here, and a box here. That is more work, like considerably more work, but it does kind of get us almost close to like the concept of like almost prefabs. If I go to the effort of blocking one of these out with physics things, I could then use our handy duplicate button, right? Oh no, I just deleted it. Fine, ignore that. I can't see shit. So there's moody lighting. Why is it so dark? Anyway, I could take this, and then when I click duplicate, it then gives me a duplicate of all the physics objects inside it. Turn fog down. Is that it? That's a little bit better. I think just because I think all these lights are turned down quite low, so I could see them. Like if I just grab this, this light is a real pain to grab, by the way, because it thinks I'm grabbing the bounding box. There you go. That's a bit better, I guess. Anyway, lighting needs to be tweaked. It doesn't help that the background's black as well, I think. But anyway, so that's the other thing to do. It's going to be kind of like a light ECS. I'm not really that interested in going for a full-blown ECS. Like the entity is just a container for things that may or may not be there. Do you know what I mean? There's no like I will always iterate over entities and just check if the thing's in it or not. The box did work, yes. Yeah, again, like different frame rates and stuff is all future problems. Like they're all solvable problems, but they're not the problem I need to solve now. I think we need maybe like an intensity for the ambient light. Because yeah, I want to be able to walk around this. It does seem very dark. I don't know why it's so dark. Like I wanted it to be dark to start with, but is it just because there's probably just no lights in the scene, right? Can I just add a light? Where's that light? I think that's better. Switch the lights on. Oh, no, it looks like shit. Anyway, it doesn't help that I probably need to also as well. There's probably other stuff as well here. There's the tone map, isn't there? So I don't. Can I? One of these. I suppose I could. Gamma seems a little bit low as well. That should be a bit higher. And then I've also got the exposure. Yeah. Anyway, those are the two options. I haven't decided which one I'm going to do yet. I'll probably do the slightly more complex one because I think it will, whilst I'm not, it does feel a little bit like I'm trying to solve a problem I don't have yet. I think that is the easiest way to kind of get us moving a little bit quicker because I'm going to get real bored of drawing all these boxes. Whereas, because you have to remember, a lot of these in this corridor here are all repeated. So it's kind of just the same object, right? So what I should be able to do is I should be able to add one, right? Then like delete this, duplicate this, move it over, and then we should have like physics. I don't know what happens if you have two rigid bodies like pixel perfectly butted up against each other. I'm hoping because of the way the jolt capsule is going to work, we should just kind of slide over it. But anyway, I think that's what we'll probably do next stream. Is have a think about that and have a play around with that. Really washes out the bloom though is the only problem. Because I could like really ham that up. Let me bloom mips. Whoa, yeah, this needs much more filtering. Sorry, I'm just faffing around now. It's just fun playing with this. Like we built like an incredible amount of stuff, and it's just really fun just kind of just playing with it. It's very Oblivion-esque bloom, that just like absolutely wang everything up. But it's looking pretty good. Like I think this is looking. I'm feeling confident. I can almost see the vision. Yeah. So, yeah, where are we at? So yeah, I think what I'll probably do is we'll probably have a play. I think it's worth spending a stream elaborating it, right? So what we'll do is on where we're at Sunday, we will straight off the bat, we will start adding physics entities to the physics handles to the top level entity thing, and then add something to be able to draw them, and then yeah, we'll make sure the duplicate duplicates that. I think I'm hoping that'll work. And then yeah, I think we'll just once we've got something down, we should be able to see that red box hit the floor, which is the most important thing. And then yeah, we'll just add a character controller. Like I really don't think with that many streams of having sort of semi-usable physics. Do you know what I mean? Like I reckon two or three streams we'll be walking around a level, and we can extend the level a bit so there's like a loop, so there's actually somewhere to walk. You know, we can bring in some extra stuff, add some visual stuff. So I think yeah, I'm hoping we're only famous last words. I'm hoping we're only a handful of streams away from being able to walk around a level. There's going to be an interesting thing there where we're going to want the debug mode to be able to fly, but when we go back, I think we're going to have 2 separate cameras. I think we're going to have a player camera, a debug camera, and then F1 switches between those 2 modes. So when you always go back to where you are, and then we might want the physics paused in the debug mode. I don't know. So you can see what's going on. Undecided. Lots of stuff to consider. Maybe a toggle option to turn it on and off. Anyway, I am just gassing now. That's all I've got. Thank you very much for coming along and keeping me company. Yes, I've already got the Jolt demo built in Visual Studio, and I will be basically pretty much copying their example one, and then my plan is to find out where all the knobs and dials are and expose those as ImGUI widgets, and then we can tweak it to make it feel how we want. Because I've got a rough idea of like the character feel I want in mind, but we just need to be able to tweak it, but like value wise, and then obviously we can serialize that out and save it and reproduce it. that's what I've got. I've said that several times now. Thank you. Oh, new video soon. Like soon. Like I filmed it. It's in DaVinci. I've not started editing it yet. So however long it takes me to edit, and life next week? Question mark? Maybe. Let's hope for that. Don't hold me to it. I don't know how many story points it is, but I can give you an update at the next party poker planning meeting. Other than that, thanks for keeping me company. I might try and do some editing now, or at least have a beer, and I'll see you all anon.